In this problem, we're asked to find the moment about the x-axis here. Alrighty then. What we need to do is first take the moment about any point on the x-axis. We could take the moment about O, but I'm going to take the moment about this elbow right here because the R from that elbow to where the force is a little simpler. Well, moving on, what we have to do first is get that R. Let's give that elbow a letter. Let's call it E for elbow. We need to get R from E to B. And just walking from E to B, I can see that I need to go 0.4 in the Y direction. And I need to go down to B 0.2 meters in the Z direction. We're given F, and so now we can get the moment about E. The moment about E is R from E to B cross F. I'm not going to show you all the details. I'll just do all this and I'll come right back. And that cross product ends up being 20I minus 60J minus 120K Newton meters. Step red is done. We got the moment about E. The yellow step is to get the unit vector. Well, the unit vector is, we want it on the x-axis, so the unit vector is just I. And then finally, step yellow is ME dot the unit vector, which is 20I minus 60J minus 120K dot the unit vector, which is I, and of course I dot I is 1, and I dot J and I dot K are 0, and the answer is 20 Newton meters, the moment about I. In this problem, we're asked to find the resultant couple. Let's go through this problem and look for all the couples. They're equal and opposite, so there's 400, 400, equal and opposite. Let's see, there's a 200 and 200, equal and opposite. And finally, there's this 300 and 300, equal and opposite. We have 3 couples. So what we're going to do is just add up the 3 couples. We'll add them all up, and we'll count counterclockwise as positive. The red couple, remember, it's the force times the perpendicular distance between them, which is 2 meters. The orange couple is 200 newtons times their perpendicular distance, 0.2 meters. And the green couple is 300 newtons, and their perpendicular distance is 5 meters. We need to get the sides to add them up. So the red couple, they are spinning counterclockwise if you look at how they're situated, so that's plus. The orange couple, the 2 together, they're spinning clockwise, negative. And the green couple is also spinning clockwise, negative. And adding them all up, I get minus 100. Oh, I didn't multiply them out. Just a minute. Before we add them up, we got to multiply them out. So that's 800 Newton meters. That equals minus 40 Newton meters. And this one is rather large. It's minus 1500 Newton meters, and that's what we want to add up. I'll do that and come back. That comes out to minus 740 Newton meters. The resultant couple is, let me write this out, the resultant couple is 740 Newton meters clockwise. There we go. That's the final answer. In this problem, it's going to be really hard to find, at least for me, it will be really hard to find the perpendicular distance between these two 10 kilonewton forces. So the first thing I'm going to do is break the 10 kilonewton forces into their x and y component. That's 6 kilonewtons. Of course, that's also 6. And the y components are 8 and 8. Now it's much easier to get the perpendicular distance. The green perpendicular distance is 4 meters. And the red perpendicular distance there is 2 meters. Taking into account the signs, let's get the couples. The red couple is a force times 6 times a perpendicular distance separating them of 2 meters, and that's 6 kilonewtons. And that pair of red forces is spinning counterclockwise. I'm going to call that positive. And for the green ones, we have 8 kilonewtons is a force, and they are separated by 4 meters. And the pair of green forces, they're spinning clockwise, so that's negative. And we're going to multiply those out and add them all up. And I'll just do that in black. So this will be 12 kilonewton meters. And this will be minus 32 kilonewton meters, minus because it's going clockwise. And the sum will be minus 20 kilonewton meters. And the resultant couple is 20 kilonewton meters going clockwise. So there we go. That's the final answer. In this problem, we want to replace all these forces and that 200 Newton meter couple with a single force and couple at O. All we're going to do is add up all the forces. Before we do that, let me break that 450 Newton force into its x and y components and come right back. That 450 Newton force breaks down into 390 newtons going down and 225 newtons going across. Okay, now we can add up all the forces. Let's add up the x forces first. Okay, we have minus 225 going to the left, and that's it. There are no other x forces. We'll add up the y forces. We have that minus 390 going down, and we have that 200 going up, so that's minus 190. That'll be Fy. And the last thing we need to do is get all the moments about O. That's what it's asking. We have that 390, and it has a perpendicular distance to O of 1.5, and I traditionally take counterclockwise as positive. That 390 times 1.5 is going clockwise around O, so minus. We have that 225 horizontal times a perpendicular distance from O of 0.2 meters. That is going clockwise. And finally, you have that 200 Newton reaction going up, and it has a perpendicular distance of 3.5 meters, and that's going counterclockwise, so positive. And don't forget that 200 Newton meter couple, which will be a 200 Newton meter couple anywhere. So you just add that in. That's going clockwise, so minus 200 Newton meter. And all that's left is to add this all up. Multiplying the forces times their perpendicular distances, we get that. And so when you add it all together, including that minus 200, we get minus 40 Newton meters. Let me just paste in the original problem and what the answer is we're getting. Those forces, the 450 Newton, the 200 Newton, and the applied 200 Newton meter, they are equivalent to 225 Newtons going that way, 190 Newtons going that way, and a clockwise moment, let's see, that way, of 40 Newton meters. These two pictures are equivalent.